Bismillah ar-Rahman ar-Rahim. This June 2020, 42 variant question number 4. And topic is a linear momentum. A smooth sphere AB of equal radii, mass 4 and 2, respectively, lie on a smooth horizontal plane. It means this is a mass AB given by him. Initially, B at rest, and A is moving speed of 10. After this collide, they continue to move in the same direction with a half of speed of B. So let's start. So Bismillah ar-Rahman ar-Rahim. So we have this situation. You can see here. Okay. All right. So just before collision and just after collision, we plan here. This is A particle, this is a B particle. Okay. And mass of the 4 kilogram, this 2 kilogram. All right. And this is going towards right side, speed of 10, he given us. And U2 is naturally at rest. And he mentioned that A continue to move the same direction with the half of speed of B. So it means V2 is, let's say, X. So V1 100% half X. And both are going in the same direction. So no negative velocity. I think idea is clear and formula is very clear. M1 U1 plus M2 U2 is equals to M1 V1 plus M2 V2. Okay, now I'm plugging the values 4 tens of 40, 4 tens of 40, and 0. So half x into 4, so we got a 2x. 4x into 2, we got a 2x. And ultimately, I got a 40 equal to 4x. And 4 divides, and we got a x. So x is coming 10. So this is a velocity of B. So I can say velocity of B after hitting is 10 meter per second. And velocity of A is naturally half, become 5, so become 5 meter per second. So I think he was asking for B only. So Alhamdulillah Rabbil Alameen. Maybe we need this part next, maybe. Okay. So let's go for part number 2. A third small smooth sphere C of 1 kilogram, same radii like AB at rest. Okay. And B collides with the C particle. After this collision, B continues to move in the same direction as, but is 1/3 of speed of C. 1/3. Okay. So now let's make again same situation we have here. And he mentioned here, okay, and one before collision and one after collision. This is before collision, and this is after collision. Okay, so what is this is a mass B, and this is C, this is B, and this is C. And C mass is 1 kilogram, whereas B mass is 2 kilogram. Okay, now you know it very well. B is the first stage, the last velocity after collision. B is just 10, will become starting speed at here. And this is at rest. It is very clearly mentioned. And he mentioned clearly that both move in the same direction. But what is a V1? According to situation, he said that after collision, B continues to move in the same direction, but 1/3 of speed of C. So let's say this is a Y. So this is 1/3 of Y. Okay. So I think this is a very clear approach. Now I can do the question easily. 10. What's the formula? Formula is very clear. M1 U1 plus M2 U2 before collision. M1 V1 plus M2 V2 after collision. So let's try to solve. 10 into 2, I got 20. 0 into 1, I get 0. Okay, half and 1/3, we got a 2/3 of Y. So Y into 1, I got a Y. If I take LCM, 3 ones are 3 plus 2, 5. So 5 by 3, Y is equals to 20. So this is turned to be Y values turned to be 3. So this has become 4. That's 12. So Y values 12. So velocity of C is very clear. is 12 meter per second. But plug in 1/3 of that, so velocity of B is 4 meter per second. And what he was saying that show there's no collision between A, B. So we have one concern, 100%. So velocity of A after collision is 5. Okay, so we can see clearly from here. So velocity of A just after collision is what? After collision, we got what? We got a 5 meter per second, 5 meter per second. And velocity of B after collision is what? After collision, it what? 4 meter per second. 100%. Even we can say that, for example, A is here, this A particle, this is a B particle, and this is a C particle. So if A hits with the B first and B is, he goes C, but A is still moving towards B, okay? But if A moving towards B, look at A moving towards B with the speed of 5 and B going speed of 4. So 100%, because this is a friction is 0, because according to situation, he said smooth or smooth plane, so no frictions there. So ultimately we can say at speed of A is bigger than V, so and it will ultimately hit the B particle. So we can say that as velocity of A is bigger than velocity of B, so 100% there is a collision. So there is another collision. Okay, I hope so. Between A and B, and I believe this part is very clear. Now he's asking here for 5 marks that A and B coalesce, and then during this collision, so find the total loss of kinetic energy system due to the third collision. So we have to deal same way again, okay, but we need to find out the final velocities. So look at now here. We need to find out the final velocities. Okay, what? Again, this is A, again B, again A, and B, but there is a coalesce. So it means they will become a same particle. Okay, this A and B will go together, and I will put them in a one block. Look like that they are going together. And I believe this part is very clear. Okay, what is the mass of A and B? A mass, I think 4B is 2. 4, 2, 4, 2. So 4 plus 2 becomes 6 here. Okay, or I can write here directly 6 also, no problem. Okay, speed of this is what? We know is 5, and this speed is what? This is 4. And this speed we need to find this speed ultimate. So formula is what? M1 U1 plus M2 U2 is equal to M1V plus M2V. Logic, because they are behaving as a one particle, combined particle. 5 4s are 20, 4 2s are 8. So I think clear. And this is a 6 into V becomes 6V, because 4V and 2V become 6V. So I think clear. This 28 divided by 6, we got velocity 14/3 meter per second. So Alhamdulillah Rabbil Alameen, but this is not our ultimate target. He's saying that find out loss of kinetic energy due to all 3 collisions. It means we discuss the starting stage. What is a kinetic energy? This is 0, so we will find kinetic energy of B part only. Sorry, here. So A and B starting stage, this B is 0. We will find kinetic energy of, this is called initial of the whole system. So 4 and 10. So let's start. So kinetic energy in the beginning, half into mv square. V is what in the beginning? You know it very well. The beginning speed was 10. I think idea is clear. So 10, so half mv square. And this is becoming what? If we check it carefully, this is a 200 into 2. So sorry, 100 into 2, we got a 200 joules. This is a initial, we can say starting initial kinetic. So let's talk about the final. Okay, what is the final we have? Final kinetic energy. Final kinetic energy we have, if we concentrate, we can say that we have two. This is a combined AB, but there is C as well. And C is moving with a speed of 12. And this is also part of the system. So, and mass is a 1. So we'll find for C, have mv square plus have this combined effect 6 mv is 14/3 v square. I mean to say this is a C particle, and this is A and C combined, A and B combined particles. So, and if you check it this in calculator, and hold on, I type in calculator, half into 6 into 14/3 square, and this is coming 412/3. Okay, so this is clear, and the loss in kinetic energy of the whole system is 200 minus 412/3, which is turned to be 188/3, or in decimal 62, 188/3, 162.6667, so becomes 7 joules. And I believe the point is very clear, and the concept of the question is totally clear.